Hi everyone, in this video I'm going to run the first test for the Sync framework. If you've been following along, I've been writing about data synchronization for a few weeks now, and basically there is an article on my blog for each part of this synchronization framework. So if you want to take a look to the whole idea, I suggest you to go here to hochojeda.com and then go and click data synchronization category and you will find all the posts like from the very beginning, which is the theory, uh, till the last part so far, that is the planning the first implementation. So in this video, what I'm actually going to do is showing you the first implementation. So if we go to this article, you will see that I show the first implementation, which is a memory delta store, and also below is an in-memory database that I'm going to use to test this. And lastly, processor. So all the three parts. Okay, so here we have the code and the idea behind the code, but now let's see the test. Okay, so here I have the master that is in GitHub at the moment. I'm filtering only for the Sync framework because the entity framework implementation is also there, but I will show that like way later on this video series. So far here I have the the synchronization framework and all the interfaces and base classes. And here I have a test project to test this framework. So here I have the test for the Delta store. So if you remember, a Delta store is an interface in general. So here is basically the implementation, sorry, the definition. Then you can implement it in many different ways depending on your case. Um, the Sync framework will always use the interfaces and never use the concrete types. So that's why everything is created like by creating an interface first and then um, creating the implementations. So this test is kind of really easy. Let me show you a few methods. Here we have one method to test if we're saving deltas, um, to get the last process delta, to get all the deltas in general. So this is not so important because it doesn't show the integration, it's just testing that the implementation works. And so far, this is like completely passing like all the tests. So basically means the memory delta store is already working. So we run 4 tests and all of them pass. So um, so far so good. So the important one is here. So this one, let me try to make it bigger and put it like here. Okay, so this test is all the crude scenario. And basically what I'm doing in here is like, I'm creating a master database, which is the memory database that we created before. So it's called simple database. Then basically I create a processor to be able to process the deltas that the master will be pulling from the other clients or nodes. So then after that, I create 2 records for the master and basically I add them. If we go and check this code, when you do add, you will see that inside I'm saving a delta every time that I do an operation like add, delete, um, or update. Basically, every time I do any of those, I go and save the delta. And saving the delta is basically creating a delta object and passing um, a simple modification item. And the modification basically is an object that contains an enum So the num contains which operation are you doing at the moment, add, delete, or update. And also, let's go back again. It contains the record. So basically, every time that I add, update, or delete, I save a delta with the type of operation that we were executing and the state of the record, or the complete record in this case. So, okay, let's go back to the integration example. So we have a database for the master, and we added 2 records. So then we will create 2 clients, client A and client B. So here we have client A, and it's exactly the same process as we did in the master. You declare a delta store, then a database, and a processor. So, and after that, I add 2 more records. So the first 2 records that I added were 2 records with the text hello world. And the next one is with the same, but in Spanish, so it's hola mundo. So client A is writing hello world in Spanish, basically. And then I do the same for the client B, or the node B. And in this case, instead of hello world, I do Привет мир, which is hello world in Russian. So far so good. At this moment, we have 3 different databases, and all of them uh, created records. So all of them, since are using a delta store, are tracking those different. So right now we have 3 databases with 2 different records each, and all those differences are saved in 3 different delta stores. So here in point 11, what I'm doing is, see, I'm getting the deltas from each different database. So it means that I have the difference created by database A, the difference created by database B, and the difference created by the master. So so far so good. It's like we have the data and the deltas, I mean the differences. So after that, what I'm going to start doing here is like, okay, I'm going to tell the master to process the deltas from database A and the deltas from database B. Every time I process deltas in the delta store, I save the last process delta index. So the idea goes like this: is I'm telling basically this should include a server in the middle, but this is a more simple case. It's like get me all the deltas that are not mine with the index that is greater than this one. So at the beginning, the first index is basically all the number 0 for a GUID. So here, I mean, we're processing the deltas and we're saving the last position, the last one that we track. Okay, so we do the same for all of them. So in the end, here in step 15, basically what I'm doing is I'm doing a for each to show the content on each database. And since we processed the deltas in all of them before, you will see that the content of each simple database will be exactly the same. So that's what I'm doing here on step 15. So I'm going to put a breakpoint here before we move to step 16, and I'm going to run this test. So let's run it first time. Okay, so here is what I want you to see. See the console. Here, remember that here in this part, in step 15, we are writing to the console all the content. So this is the data in the master. As you can see, we have all the same records in the 3 databases. The things that are different is like, okay, the order is different. So for example, in the master, the first one is hello, and basically each database has a first record, the record that they inserted first. But it doesn't matter, because if you sort them by the GUID, which is the key, you will get the exact same sorting on all the cases that means the data is basically the same, right? But in here the order is different, even though the content is the same. The other thing that you will see that is changing is the index, because once you save the deltas in the master, um, uh, basically the last index process was the last index from the database B. So in this case, it's different. But A and B share the same last or max delta, basically. So it means that each database is keeping track of the deltas that has been processed to not request the same again and duplicate the operations. So let's continue. Then I will do two operations. So I will do a delete operation. So this means that the master is deleted and we are recording that as a difference. And then we will propagate that in all the nodes. And also we are updating one of the records in the master. So we deleted the record which was with the word hola. And then the record with the word mundo, which means world in Spanish, um, will be updated to say hola mundo, like in just one word. So basically, we're doing two modifications to the master database. And then we're going to do the same process to get the deltas for each database and then process them in all of them. So it means that at the moment that each of the database has processed all the possible deltas, all the database should be on the same state. So basically, at the beginning, we used to have 6 records on each database. In the end, we will end up with 5 because we deleted one and we updated one. So let me continue this. We do all the crossings of delta information there. And here we're about to print the results again. So you will see that there are like 5 records instead of 6 on each database. And all of them will contain a record that says Hola Mundo. And none of them will have one which only says Hola. So let's continue. And let's go to the output. See, this is the next output. So Hola Mundo, Hola Mundo, and Hola Mundo. And none of them has a record which has the text Hola. And also all of them only have 5 records. So 1, 2, 3, 4, 5. Because we delete one and we updated one. So basically this test was successful. Let's continue and finish. So this is the first use case. We are creating difference by updating, inserting, and deleting records in an in-memory database. And then we are keeping track of those differences, um, processing them on other databases and see if the state is the same. So far so good. There is only one test on this class, but it's more than enough because we covered all the crude scenario. Of course, as the time goes by, I will be creating more and more and more test scenarios, right? So I will not go as deep as unit testing, but at least we have the integration scenarios. So that was it for this video. If you are curious about the synchronization framework, download the repository in GitHub and run the test and try to see how they go. So in the next video, what we're going to do is we're going to make this a little bit better. So far, all the databases have been declared in the same executable. So that's not how in reality it should work. There should be somehow like a network layer that you can go and ask to a remote server, give me the deltas, or here are my deltas. So we will make it better on that way. But I think I will write a few posts before that, before the next video. So, well, again, that's everything for this video, guys, and see you on the next video. Bye.